Hello students, this is Mr. Yao. In this whole unit, we have learned about different kinds of statistics. And now we are going to learn how to use Desmos, a mathematical tool, to deal with all the stats that we have learned. So let's get started. So please open a website called www.desmos.com/calculator. And as we go, please make sure you have that website open and keep trying as we go through the examples. Let's have a look. First example, these are the numbers. Let me also open Desmos myself, and here are the questions we are going to go through. Here we go. So to find a mean in Desmos, it actually had something called mean. So here's what we can do: mean. We just type in the word mean, parentheses, then we're going to type in every single number that is given in the question, which is 68, 76, 61, 78, 68. All separated by a comma: 70, 40, 60, 22, 51, and 54. Parentheses back. Okay, you can see the mean is right here. So that is how we find the mean, and you can round 2 decimal places to put it in your notes. Now make a guess, how would we actually find median? Well, median in Desmos also has the word median, M-E-D-I-A-N, and you can technically just go to the top and copy down everything, single thing you have just typed in, and move it to the bottom. There you go, 61. Okay, and next, oh, here's the thing. You see, every single time, if you didn't actually copy the numbers down, you almost have to type in the numbers every single, well, one by one. So here's another way we can do it. We can actually click plus and actually make a table. We don't need anything for y1 since we have just numbers for x1. Let's type them in: 68, 76, 61, 78, 68, 70, 40, 60, 22, 51, 54. Again, after you finish typing each one, you can press enter. And now instead of calling the mean with every single number typed in, I can just do mean and put in this x sub 1. So in order to type it in, it's x, then this little dash key 1. So to show you again, in order to type it in, this is what we actually do. We are going to write down x1. That's how we actually type in x sub 1. So it's actually mean, and then parentheses x sub 1. That's going to give you this little subscript. Okay, and then we can do the same thing: median x sub 1. And you do need to actually use the right arrow to get out of the subscript to keep typing in. There you go. So that's the median. And we can see we got the same answers. Next, quartile and standard deviation. Quartile has a little setup. So let's type in the word quartile first. Q-U-A-R-T-I-L-E. You see there's a little mark on the left side. It says quartile is a function. Try using parentheses. Okay, so we can type in parentheses. And now it actually tells us something more. Function quartile requires 2 arguments. For example, you need to type in, here's the data set, and then comma 1. So the setup is Q-U-A-R-T-I-L-E, and then the data set, which is x1, and then the next part, this could be 1, 2, or 3, because we have quartile 1, quartile 2, quartile 3. So let's try that. X sub 1, right arrow to actually get out of the subscript, then 1. There you go. Oh, I actually put one more. Okay, there you go. That's quartile 1. And now I can actually copy down the same thing to find quartile 2. And think about it, quartile 2 is actually the median, so that should get the same answer. There you go, 61. And now I can do the same thing, but this time I'm going to change the 1 to a 3. So there we go. As you can see, we now have quartile 1, and quartile 2 is the median, and then quartile 3 is right here. Let's move on to find more. Here you go, more questions. Now, standard deviation. So standard deviation is kind of an abbreviation of the word. It's ST and then DEV. Okay, and it tells us we need parentheses. Okay, let's type parentheses. And then we can just type in the numbers. So we already have, you can either type in all the numbers, or you can actually now just type in x sub 1. There you go. Oh, I forgot to get out of the subscript. So there you go. That is my standard deviation. Typically, you would actually need to copy down that number, which is 16.603942577, and then square it. That's actually going to give us the variance. But now we actually don't need to do that anymore because variance is also a function in Desmos. VAR, and then is x subscript 1. Get out of the subscript. Okay, there you go. You can see the numbers are very close. Well, of course, because this one, even though we write so many digits, it's still rounded. So this is the more precise answer. That is variance x sub 1. Okay, however, we do still need to calculate IQR by using Q1 subtracting Q3. So in this case, Q3 minus Q1. Q3 is 70, Q1 is 51. So IQR would have to be 19. Okay, afterwards, well, here, this is everything, but you might be like, wait, what if I don't remember like how to type these things in? What is the format? Well, here's something else we can do. You can see this little button right here. It actually says show keypads when you hover over it. There you go. You can either type in letters if you need with a bunch of other things, or you can choose to type in numbers with all the different functions. Okay, and now there's more. Here's functions. Sine, cosine, tangent, well, these are trig that you will learn next year, including inverse trig. You can see there's a stats, list operation, visualization. We're going to talk about that in a bit. And then distribution, well, these are the things that you will learn in the future in statistics. And there's more. Then, of course, there's calculus and hyperbolic and geometry stuff. There you go. So there's quite a lot of functions. The question here in your notes is, where can we find statistics-related functions? So I have to click functions. They're all right here under statistics. So there you go. And now you're going to have a look at all the list to see what are some functions that we have learned. So there you go. Mean, median, minimum, maximum, quartile, standard deviation. And this is the standard deviation for population. And then there's variance, correlation, coefficient, and count how many numbers we have. And this is to actually calculate the total of all the numbers. So you can see there's quite a bit of stuff. Now there's also this thing called stats. Let's see what that actually is going to return to for us. So let's actually type in the word. You can either click on that or you can type in the word STATS. We're still going to call our x sub 1. There you go. We're given the 5-number summary all together. So minimum of 22, and then Q1 is 51, median is 61, Q3 is 70, and maximum is 78. So we actually got all those numbers we did find with the median, quartile, 1, 2, and 3. So there you go. That's a faster way to find the 5-number summary. That's basically everything that we can do with Desmos to find one of our stats. That's the thing that we have been doing with calculators. Now please pause here and try to work on the following questions with the following data set. Hopefully you have tried this question, so let's move on. Next, we're going to use Desmos to generate histogram, dot plot, and box plot. You can either use the current website you're still on and just go to the bottom, or you can actually open another one, desmos.com/calculator, then create a table and type in this data set. You can pause here. Okay, so it should look something like this. So for this example, I'm actually going to ask you to watch the video all the way through until we're done with Boxplot, dot plot, and histogram, and then you can pause it to go back to your website and try to do it yourself. So let's start with the Boxplot. If you recall previously, when we're going through the functions, if you go down, there is the Boxplot, dot plot, and histogram. Of course, you can choose to type in these words as well. So let's just type them in. Boxplot. And I want x1. Well, as soon as you type in boxplot, it will first ask for parentheses, of course, and then it says enter the data set. Our data set is the x sub 1 that we just entered and created above. Okay, and you look at the right side. Well, where's my dot plot? Where's my box plot? Well, of course, because all the numbers you have are above 10, so you do need to drag the graph a bit over to 10, and voila, that's your box. And if you think it's too small, you can actually zoom in. That might give you some better numbers. You can see this is 10.1 right here, and it's going all the way to 11. Or here's another way. If let's say this is what you got, and you see this little magnifying glass, click on that, zoom fit. So it will fit right in the center of the screen. So there you go. That's all the values that we have. You can either choose to exclude the outlier or include the outlier, depending on the different data set. Okay, next, histogram. Histogram, oh, I spelled it wrong. H-I, okay, there you go. Histogram, of course, we need parentheses, and it says data set and bin width. So data set is our x sub 1, and the default bin width is 1. The default is 1. Of course, I mean, if you choose 1, you can see it just, the whole thing is like not quite separated. So we probably don't want that. Since all the numbers are just point something, let's say we want the bin width to be 0.1. Then suddenly it looks like this. There you go. That's what it looked like. By the way, if you don't like the color, you can click the little gear and click on this little color, and you can change a different color. Let's say we want blue. There you go. Okay, and then click done. Okay, so this is if it's 0.1. Right now it's centered because the first time we have is like 10.1, and then it's 10.2. So the numbers we want are actually in the middle of each of the bar. If you don't want that, you can choose left, and then it's 10 and 10.1, 10.2, 10.3, 10.4. They look similar, but a little bit different. let's say you think 0.1 is too small of a bin, then we can do 0.2. And that means we only have 6 bars. Or if you don't like that, 0.3, depending on what you need. So that's how we could deal with a histogram. Okay, next, we also have dot plot. We still need data set and bin width, so x1, and then you have a bunch of dots. However, the bin width right now default is 1. Let's say we don't want that. Well, then in that case, we can do like bin width at 0.2 as well. So there you go. That's looking a little bit different, but it's still going to be a dot plot. And you can either choose it left or center, depending on where you're going to count a certain dot. But you might be wondering, what exactly is this bin width? We actually have learned before. When we learned about histogram and dot plot, we actually didn't call them as bin width. They were called class width. And they actually mean the same thing. It's just how big is your little interval to start including or to start counting numbers. So there you go. And that is the dot plot. Now you can pause here and try to generate the whole thing on your own website. Hopefully you have tried generating histogram, dot plot, and boxplot. Let's move on. Next, we need to know how to use Desmos to find or generate the line of best fit and find the correlation coefficient and also generate the residual plot. So let's use the following data set, X in the first row, Y in the second row. Same thing, you can either use the current website you're on or open another one and then create a table to put X and Y in there. Of course, so here's it is, create a table in Desmos to type in the data. We have gone over this already. We clicked the plus symbol. So let me actually write these words in. Table, we click the plot symbol. Oh, I do need to have it there. On the top left corner, and then we're going to click table again. Afterwards, we can actually put in the x1, y1 from our table here. It should look something like this. Next, in order to find a line of best fit, here's what we are going to actually type in. We want to use the y1 values. So we do need y sub 1. However, we're not exactly using just these values. We want to actually use the relationship between them to generate. So we can't type an equal sign. Instead, what we're going to do is a little shift with a dot on the top left of your keyboard. So here's exactly what we typed in. I typed shift. While I hold on to it, it's the little symbol. It's this key on your keyboard, top left under the ESC key. There you go. It's actually not that direction. This direction. There you go. Afterwards, it's a x sub 1 because I do need the relation between x1 and y1, and then a plus b. There you go. Now you can see my a value is given, my b value is given, and I also have the r. And that's exactly what we can do to generate the line of best fit. But you might be wondering, like, wait, how come I'm not seeing anything on the right side? Well, of course, because the numbers you see are bigger than this current graph is showing. So we need it to be a bit more. So we actually need to zoom in. You can click this plus symbol again. Voila, everything is zoomed in. Technically, as soon as you type in the table, these green points would already be here. Okay, and now you might be wondering, so I have all of these, I have my line of best fit, how do I actually create the residual plot? So here's what we're going to do. You see this little key right here says plot under residual. I'm going to click on that. There you go. Everything is already given right there. But at the same time, you can see just a lot of green dots. And let's say you don't like that, you actually want to see different colors. Then same thing, click the gear. And let's change all of these into, say, red. Okay, so your residual plot is all in red, and the green dots are actually from your scatter plot. But now let's say you don't even want to see any dots from your original scatter plot. Then click on that. All the points are gone. But somehow, well, this line clearly does not fit anything that we see in the residual plot, so I can also click on that column to make that disappear. There you go. And now I only have the residual plot, and if you want to see closer, I can click zoom in, or you can just drag it around and make it bigger, so you can kind of see it a bit clearer. And as soon as you actually put your mouse on each of the point, they're going to show you the actual value of that point. So there you go. That's how we actually find the residual plot. Next, let's talk about how to actually get the predicted values. So let me actually put everything back. So we have the line of best fit, we have the original scatter plot. Okay, yours might actually not be here in the third column. Yours could be should be on the right side. But now let's say we just want to find the predict value. Remember, the predict value come from the A and B. So I actually need to type these into the third column. So it's going to be negative 0.510607 times x sub 1, and then plus my b is 42.0957. There you go. Now I have all the predicted values right here. They're currently in purple. If I don't want to see anything else to actually confuse myself, I can actually just make them disappear. These are all the predicted values. They're of course going to be on the line of best fit because the predicted value is by plugging each one of these x values into our line of best fit to generate. So there you go. I can bring back the original points, and I can also bring back my residual plot. So that is how we can actually do the line of best fit. So now you can actually try with this practice question. But that is everything we are going to learn about statistics with Desmos. Thank you.